We carry the entire world in our pockets. With modern satellite imaging and instant GPS tracking, it feels like human technology has finally mapped, measured, and conquered every square inch of the planet. Take the Four Corners Monument in the United States. Surveyors laid this exact intersection in 1868 using basic 19th century equipment. Yet modern GPS confirms they nailed the precise meeting point of Utah, Colorado, New Mexico, and Arizona. It is a monument to human-imposed order. But beneath these meat borderlines and calibrated coordinates, the Earth is actively resisting. There are pockets of extreme geography that ignore the laws of physics and biology we expect them to follow. Flat, static maps offer a comforting sense of control. In reality, they are papering over a restless planet filled with geographical anomalies that act like glitches in the physical world. Deep in the Peruvian Amazon, there is a 4-mile stretch of water called the Shenandoah Tempishka. Local legends spoke of it for centuries, but scientists largely dismissed it as a myth until a geologist tracked it down to prove it exists. This river reaches temperatures near 200 degrees Fahrenheit. It is hot enough to cook any animal unfortunate enough to fall in, boiling them alive in the current. This map plots the river's location. Hot springs usually require a magma heat source, but if we zoom out, you can see the nearest active volcano is over 400 miles away. There is no surface-level reason for this anomaly to be here. This anomaly highlights how much of the planet's internal heat remains hidden, leading us to investigate other places where the Earth seems to break its own rules. Even the most reliable force we know, gravity, seems to lose its grip when weather and geography collide in specific, violent ways. During intense coastal storms in places like the Faroe Islands and Ireland's Cliffs of Moher, waterfalls flow backward. Hurricane-force winds slam into the sheer rock faces and blast the falling water straight back into the sky. We can see another fluid anomaly by looking at this cross-section of the Black Sea. Sonar has mapped an entirely separate, massive river flowing along the ocean floor, complete with its own underwater rapids and plunging waterfalls. The diagram shows exactly how this operates. Heavy, hyper-salty water from the Mediterranean Sea pours in and sinks, flowing rapidly beneath the lighter, less dense water of the Black Sea above it. By volume, if this current were on land, it would be the 6th largest river in the world. Surface gravity dictates that water falls down and pools at the bottom, but extreme atmospheric conditions and chemical densities can hijack those mechanics. Subterranean plumbing explains the mystery of our boiling Amazonian river. Rainwater seeps deep into the Earth's crust, is heated by the planet's geothermal gradient, and is then forced back up through fault lines to create a natural heating system. Move from the extreme heat of the jungle to the sub-zero environment of Antarctica, and you will find the Taylor Glacier. A bright red liquid continually bleeds from the ice, flowing directly over the white landscape. This is the result of an ancient underground lake that was sealed off for millions of years. When that hyper-salty, iron-rich water finally squeezes through fissures in the ice and hits the oxygen-rich surface, it rusts. A similar reaction happens at Indonesia's Kelimutu volcano, which features 3 separate crater lakes. Depending on the shifting volcanic gases and mineral levels interacting beneath the surface, the waters cycle through shades of blue, green, black, and red. The Earth's crust acts like an active chemistry lab. It is constantly brewing reactions that contradict the climate of the surrounding environment. Look at this topographical map of the Pacific Ocean. If we lower the water level, an enormous landmass emerges around New Zealand. This is Zealandia, a submerged continent twice the size of India that is almost entirely hidden from view. While Zealandia hides underwater, the visible giants challenge our understanding of scale. Russia spans 11 time zones and covers 17 million square kilometers. If you laid the entire surface area of the dwarf planet Pluto flat, it would comfortably fit inside Russia's borders. This scale affects more than just distance. It reaches into the fundamental laws of attraction. In Canada's Hudson Bay, gravity is measurably weaker than the global average. During the last ice age, the weight of massive glaciers compressed the Canadian landmass downward. The Earth is still slowly rebounding from that depression, meaning there is less physical mass in that specific area today, resulting in a localized drop in gravity. Human perception often misses these subtleties. Earth's mass is distributed unevenly, creating localized variations in the physical forces we take for granted. When you pull back from all these isolated anomalies, the boiling rivers, the upside-down waterfalls, the variations in gravity, a clear picture forms. The Earth is an actively shifting machine. Even our most rigid landmarks are in motion. Mount Everest is the highest point on the surface, but because the Indian tectonic plate is driving into the Eurasian plate, the mountain grows approximately 4 millimeters taller every single year. While the Himalayas are pushing further into the sky, other landmasses are vanishing. At an average elevation of less than 8 feet, the Maldives face the mathematical reality of sinking